Hello class, welcome to the next segment in the week 6 material. And in this segment we're going to talk a bit about the idea of a module, which is something that's really nice to know about because it turns out that a lot of scientifically oriented operations that you can do in Python are modules that other people have developed, offered up for publication, and it turns out many of these modules are something that comes with the Anaconda installation package, and a lot of this stuff is already installed on your computer when you download Anaconda, and you just simply need to know how to make use of it. And one of the more useful and versatile modules would be the math module, which holds onto a collection of special math constants, which we'll explore very shortly. But more importantly, these hold on to some special mathematical functions. And this kind of goes back to a point that I made in the second segment about how if you want to evaluate the cosine of some number or some angle, the only way you can really accomplish that is by evaluating a Taylor series polynomial, which is very complicated and very tedious. So it'd be nice if we had a function that just simply evaluates that polynomial for just any value that we pass to the function. And fortunately, that is something the math module does for us. We simply can pass an angle to a sine, cosine, tangent, or whatever trigonometric function that we want. We just simply pass that angle to the function. It gives us back the result, the sine of that angle, the cosine of that angle, or whatever it might be. So this is sort of going to illustrate the process that we talked about, or the idea that we talked about in the second segment about how we can take something really complicated like a Taylor series expansion and distill that down into something that is super simple and super easy to work with. So one thing that we should also go ahead and mention is this is where the import statement comes into play. This is something that we've kind of hinted at and alluded to in previous segment, but here I'll actually explain the importance of this import statement. Now, when you have a module that you want to bring into your program, that you want to actually access as part of your program, that's where this import statement comes into play. So in this case, we want the computer to find the math module and bring all the stuff from that math module into the computer's memory so that we can actually access the information that's contained within the math module. This is very important. If you don't include this in your program somewhere, then you're not going to be able to do any of the complex math that we're about to demonstrate. And also, sort of a best practice, when you have import commands, it's a good idea to put those at the very top of your code, that is, of your Python program. That's just sort of a best practice that is recommended for all programming languages. All your import statements should go at the very top. So bring the math module into the program. And here we have two variables that we're going to be using just to demonstrate, not that, we're going to be demonstrating the stuff that we have as part of the math module. So let's actually go ahead and focus on just one of these things at a time. So let's take a look at the sine function that's part of the math module. So again, module, a collection of functions and also variables that someone else has put together and is now accessible for our use. So one of which is the sine function. So we just simply pass the function an angle, and the result we get back from that will be the sine of that angle. So we're saying take the sine of x, which we set equal to 10 here on line 4, take the sine of x and get a result back from that. Now, something that's very important to keep in mind when working with the math module in Python, all of the trigonometry, underscore all of the trigonometry, is done in terms of radians, not degrees. It is done in radians. So this sine function on line 7 is in fact calculating the sine of 10 radians, not 10 degrees. That's something that a lot of beginners seem to forget about whenever they go to work with any of the trigonometry here. Everything, all the trigonometry in this math module is being done in terms of radians. There is not a smidgen of degrees anywhere in the math module. It's all done in radians. So if we want to see what the result of 10 radians is, we can just run this portion on line 7 here. So we're telling the computer to print out the result that we get back from the math.sine of 10 radians or x radians, and you can see the result is that lovely number, negative 5.44 plus some other excessive decimal places. Now, another point that I really want to make early on is the difference between what we just did and the difference between attempting this. So what we had earlier, we had math.sine of x. That tells the computer to go into the math module that we imported up here and find a function called sine, S-I-N. If we remove that portion, then it's going to be looking for a function that is actually defined within the program itself. That is, it's going to be looking for a function like this. So, math.sine x means go into the math module and look for a function called sine of x. That is something that's contained within the math module. Sine x without the math dot portion in front of it, just this portion here on line 10, means look for a function called this defined within the current program that is something like what's here on line 4. So this actually won't really do anything very nice. This is just to show you what the computer is actually going to be looking for if you do just sine x as opposed to doing math.sine x. And you'll notice that when you start typing out the name of the module, you'll see a bunch of suggestions pop up in Spider, and that will basically list out all the functions that are contained within the math module. This is just sort of a summary of some of the more useful functions that you will have access to. There are many more, but these are probably going to be the ones that you get the most use out of being in a science field. So I just want to make that point early on, the difference between math.sine x and, again, just sine x. So again, I'll just repeat that one more time because it is so important. Math.sine x means use a function within the math module, which we imported up here, use a function in the math module called sine of x, versus just this, which means look for a function that we've defined in the program using the def keyword and run that function with the value of x. So something like what I just put on line 3 here, but I'm going to get rid of that because we don't want that. And similarly, if we can take the sine of a number, we can also take the cosine of a number. So here we're going to be, again, taking the sine, or excuse me, we're going to be taking the cosine of 10 radians and getting a number for that. So the cosine of 10 radians is that lovely negative number that you see on the screen here, or in the console, I should say. And also contained within the math module are an assortment of fundamental constants. So one of which is the value for pi, which is 3.14159265358979323846264 plus a whole bunch of other lovely digits. And if we want to, this variable is not actually going to be holding on to that many digits because there's actually a limit to how many digits the computer can hold on to. But you can see that does in fact access the value of pi, again, part of the math module. And notice how this is not have any parentheses after it. So that tells us that this is a variable, a simple variable that's contained within the math module, as opposed to it being a function within the math module. And just like before, if I try to do this, it's going to be looking for a variable called pi that is defined within the program, i.e. a variable like this, which I just put on line 7. So make sure if you want the computer to pull something out of the math module, make sure you include the math dot portion in front of whatever you want to access in the math module. And another special number in the field of mathematics is the number e, which is 2.71828 and plus some other numbers. And that is especially special in the realm of calculus because e raised to the power of x, the derivative and integral of that function, is the exact same thing. Another one that we can work with is arctangent. So again, we can take the arctangent of a number, and again, when you perform arcsine, arccosine, or arctangent, the number that you put in that function, you will actually get back an angle as a result. So here I'm saying take the arctangent of the value of x, which is 10, and the result we get back will be an angle whose arctangent is, or whose tangent will in fact be 10. And again, the angle that we get back from here is going to be in radians. Like I said so many times before, all the trigonometry is done in terms of radians. So it turns out the arctangent of 10 gives us 1.47 radians. Now there's actually two arctangent functions in the math module. So one we had which was just math.atan. This one is math.atan2. And you'll notice that this one takes in two separate values for y and x. And to really understand why this is so useful, I'm actually going to switch over to this and demonstrate this with a nice vector quantity. So let's say I have a vector that is -2 units in the x direction and -2 units in the y direction. The angle for that vector would be 225 degrees, and that points in the third quadrant. However, if you were to calculate the angle of this vector using the tangent formulation, equal to y over x, again, you take the inverse tangent of both sides to calculate or to isolate the angle. So the angle here is equal to the inverse tangent of y divided by x. Now, if we plug in the values of y and x that we have here, so in this case, x is -2 and y is -2, we plug that in, and notice how we have negative in the numerator, negative in the denominator. Those negative signs actually end up canceling out, and the result we would get back from trying to plug this into a calculator is in fact 45 degrees. And looking at the vector that we have, we can see that this angle is a bold-faced lie, because that puts our angle in the first quadrant, or that puts our vector in the first quadrant, when in fact we should get a result that is in the third quadrant. And the reason why we get this confusion is because of the negative signs that we have going on in our fraction here. So again, we should in fact get 225 degrees from this arctangent function. So what this function does on line 12 here, this math.atan2, it keeps the y and x components separate as opposed to putting them in the same fraction. And by keeping the x and y components separate, then the function itself is actually able to keep track of what quadrant the angle should actually be in. So 99% of the time, if you want to take the arctangent of an y component and an x component, you are going to want to use the function that's demonstrated here on line 12, the math.atan2 function, where the order of that will be y component, then x component. And again, the result that you get from that is in fact in radians.